Hello, today we're going to talk about how to find critical points and inflection points. To start things off, let's give ourselves an equation. Let's say I have f of x equals 3x squared plus 4x minus 9. And I want to find the critical point of this function. Now what I'm going to do is take its derivative and set it equal to 0. So we have f prime of x equals, this is going to be 6x plus 4. So I'm going to set this equal to 0. So I'm going to have 6x plus 4 equals 0. And then I solve for x, so I have 6x equals a negative 4. Divide by 6, x equals negative 4 over 6, which is the same thing as saying negative 2/3. So this is my critical point. Now what I can find from my critical point is if this function has a relative extrema at this point. And the way we do that is the following. Make ourselves a little number line and mark our critical point at negative 2/3. Now I want to test some points that are going to be less than negative 2/3 and greater than negative 2/3. So for the less than negative 2/3, let's pick an easy one, something like negative 1. And for the greater than negative 2/3, let's pick something like 0. And what we're going to do is we're going to plug these values negative 1 and 0 into our derivative function. And then from there, if we get a positive value, I know that I'm increasing on that interval. And if we get a negative value, we know that I'm decreasing on that interval. So let's see what we got here. When I plug in a negative 1 into my derivative, f prime of negative 1, I'm going to get a negative 6 plus 4. That's going to be a negative 2. So I know that on the interval of numbers from negative infinity, which would be like way over here, up to this point right here, negative 2/3, I'm going to be on a negative slope. So now let's test the point 0 to find out what happens for numbers greater than negative 2/3. Let's get our f prime of 0 equals, plug a 0 in for x, that's going to get me 6 times 0 plus 4, and that's going to be positive 4. So I know in the interval from negative 2/3 to positive infinity, going like this, I have a positive slope. So what this means for my extrema is, if I'm drawing a function, let's just draw something down here, my axis. Alright, so if I'm drawing a function, coming in from the left at negative infinity, I'm going to be decreasing, so it's going to be something like this. And when I hit negative 2/3, all of a sudden I start increasing, so it's something like this. So I can see right here, this point at negative 2/3 is going to be a relative minimum, since I'm decreasing from the left and increasing from the right. Alright, the next step in this process is to find the inflection point. And that's done by taking the second derivative of our function. So let's write that right here at the bottom. We have f double prime of x. Looking back up here, I have my first derivative is 6x plus 4. The derivative of that is going to be simply 6. So what this means is that I'm not going to have an inflection point because I don't have a x equals something. I just have a constant number, positive 6. So since that's a positive number, that means that for my entire graph, the interval from negative infinity to positive infinity, I'm going to be concave up at every point. Oops. Concave up for every point in my graph. And we can kind of see that by the general picture that we drew right here. This is in a concave up fashion. Alright, and then likewise, let's say that this was a negative 6, then we'd be concave down for the entire interval. So we'll do some more examples in the next video.